Hello everyone. This is Forces of Nature, or more commonly known as talking about free body diagrams, or FBDs. Okay, lesson 3.1a. Now, we're starting a new unit, and it's the unit of dynamics. And dynamics is really about the physics of the cause of motion. Physics of the cause of motion. Okay, where kinematics was really about the how things moved. This is really about the why things move. And really, the reason why deals with forces. And so this entire unit is really built upon forces. So we've got several different types of forces that we're going to be looking at. And so we're going to run through these different types of forces. Forces just being some sort of push or pull acting on an object. So weight is simply the force due to gravity. Okay, different than mass, it is a force. It's how much gravity is pulling you. Normal force. This is a reactive force. Of surfaces. Now, it's always perpendicular to the surface. Now, the easiest way to think about this is that if gravity is pulling you down, why do you not keep falling? The answer is usually because there's a floor or the ground or something that is holding you up. And so this is that reactive force holding you up. It's holding you equal to your weight. So if you got 10 newtons down, the normal force holds 10 newtons up. If it's 20 newtons down, it'll hold 20 newtons up. So it's just a reactive force. Friction is a resisting force. And it always resists motion. Against motion. Now, this is caused by surfaces rubbing. So surface interaction is what causes this. And so if I've got an object moving to the right, the friction would be moving to the left. Force of friction. If I had an object moving north, friction would be moving south. Right? And so it's always against whichever way the object is moving. It's always the way friction goes. It's always against the motion. Tension is just the force from a rope or string. And typically what we do is we're going to use free body diagrams. And really this is a diagram showing forces on an object. Okay, and if we were to add up all the forces, sum of all forces is what we call the net force, the overall force acting on an object. Okay. So can a net force ever be zero? Think about it, pause the video, and think about whether it be pause now. Okay, the short answer is yes. We can wind up with all the forces adding up to 0. Because let's say, for example, if I'm standing here, I've got a force due to gravity, and let's just pretend this boy is got 1,000 newtons of force downwards. The floor holds him up with a normal force of 1,000 newtons, and there's no other forces acting on him. Well, 1,000 down and 1,000 up totals 0. Now, it's customary to represent by the object in a free body diagram, to represent the object with just a box or a circle. And all the forces always come from the center in the direction. Also, the longer the line, the bigger the force. So a book rests on a tabletop. Well, there's two forces. The first one is the force of gravity, pointing down. And because it's resting, we've got a normal force going up. Now, these lines should be of equal length because the force down and force up are in fact equal. And there's my free body diagram. If a girl is suspended motionless by a rope, well, again, you've got a force of gravity, but here you've got a force of tension, not a normal force, because it's a rope that's holding him up. An egg is in free fall from rest from a tree. We're ignoring air resistance, so it's just a force of gravity. It's just falling. Now, if we did not neglect air resistance, right, you've got the force of gravity acting on it, but you'll have a force of friction. Now, assuming that this is still accelerating, has not reached terminal velocity yet, the gravity will be longer than the force of friction. A rightward force is applied. So rightward force applied. So I'm just going to go FA, and that really just stands for applied. Okay. It's got gravity and the normal force acting on it. Those two lines should be about the same. We're considering frictional forces, so to oppose that motion, we got friction. Okay, if it is moving at a constant velocity, however, that applied force and the force of friction should be the same length. Again, we have the force of gravity and the normal force acting upon this. In example number 5 here, because the applied force is greater than the frictional force, it's going to be accelerating to the right because it's got a bigger force. Here, the forces are equal. There won't be any sort of acceleration acting upon it. They're all the same. Car is stopped at a light. Well, force of gravity, force normal. Right? It's stopped. It's sitting there. It's not moving. Okay, skydiver descending at constant velocity. Well, we've got a force of gravity, and what's holding it up, keeping it at constant motion, is friction, specifically air resistance. And because it's moving at a constant velocity, these two arrows should be the same length. Again, mine might not be absolutely perfect, but it should be at least close. It should be obviously in and around the same, not obviously different. If the car is parked on a steep slope, well, we've got a force of gravity. The normal force, remember how we mentioned that the normal force is perpendicular to the surface, so it's actually going this way. What's preventing it from sliding this way and down is friction, holding it in place. If a hot air balloon is accelerating upwards, the force of gravity is going to be this way, and the force being applied to it, if you remember from earlier grades, we sometimes called that lift, is going to be greater than the force of gravity. And a car is coasting to the right but slowing down. Okay, we've got a force of gravity, we've got a normal force, and these are about equal and opposite. Now, the car is moving this way, and so friction is going this way. Now it's coasting in, so we don't have any sort of pull or push going this way, so no force to the right, even though it's moving to the right, but it's slowing down to the left, right, caused by friction. Okay, that is the lesson. Hope that helps. If you've got any questions, please let me know. Take care.